Hi, I'm Peter Padd, co-founder of Fortifyedge, and I'll be joined by Malcolm Layton, my co-founder, to talk about zero trust cybersecurity, utilizing tiny machine learning for authentication and access for the edge. Every day we see new and sophisticated attacks in the news, and I look at this latest supply chain attack to just get you all thinking about what we need to deal with. Some researchers in the US hacked this Tesla simply using MCU emulator software, a credential they found on Twitter, a $1,000 drone, and a Wi-Fi dongle. And within seconds to minutes, they had full control of the vehicle, opening the doors, turning lights on and off, and they were able to weaponize that to all vehicles in the car park within seconds. And this attack is just one example of what's considered a national emergency, and SolarWinds really highlighted that. And in particular, the attack of our authentication or identity are the key vectors that the bad guys are going after. So these adversaries have become so sophisticated, they've been very good at impersonating legitimate users, and authentication has become that top target. So we've really got to ramp up our responses to that. So whether they steal your credentials or your device and credentials like that Tesla, this is what we are now managing as a threat in the new world of connected devices. And there is a strategy there to address this. Both the NSA and CISA and our peak bodies like the NIST have said to embrace a strategy of zero trust security. And that involves things like adopting multi-factor authentication, binding your identity to who you are, that is, to the hardware, and verifying every time you access a resource that's valuable, and start to adopt machine learning to detect anomalies occurring on these endpoint devices. But how do we provide zero trust to our first responders or defense personnel that are operating at the edge, where the cloud may or may not be available or it's disrupted? And authentication and how it currently works is actually hindering the mission. And if you could put your mind to that PPE operator on the right, especially in the likes of COVID, how do they access these systems while wearing all those things? And in these cases, the real threat is any delay, even seconds, could exacerbate an emergency. Our current solutions range from passwords to biometrics that work great in an office setting, but they're a distraction and could be lethal to the operators in an edge setting. They've got no time to be distracted or worried about losing hardware keys or removing protective gear to access those systems. So what we did was we turned you into the password. We built tiny machine learning neural networks that we can bet on the devices, operate the inference on the device, constantly predict, is that person who they say they are? So how you walk, move your arm or your head or something that you're carrying, all of these can be a place for a neural networks to operate in a tiny ML setting, to operate on the device, to determine if the person is still in control of it as they're operating in a connected environment. So let's move to actually show you a demonstration of how this works. The first use case is obviously the happy path or the trusted user, where they're wearing some sort of a connected device, whether it's a mobile phone or a smartwatch or a wearable or something they're interacting with. And our neural networks have learned a unique pattern about that individual, and they've provided a seamless experience, but we can also know who's accessing it at any point in time. As you can see on our dashboard, we use explainable AI to inform operators of operating centers and so on in real time of who's using that device when they're accessing a valuable resource. The second scenario, which is really the main one we want to talk about, is yes, it's great that we've provided a much better user experience, but often that comes with compromised security. But in our case, we've avoided that, and we're able to use the neural networks to identify within seconds when an adversary gets control of the device. So as they do that, the confidence scores that have been created by the neural networks on the device are able to detect them and alert on the device or to an operations center, so security folks can make a decision about resource access in real time. So we're going to show you a quick video of the actual software running on the watch, and also streaming the confidence scores to our operations center, just so you can see what this looks like when it's running.
Thanks, Peter, for that. We're going to look at the technical overview and a little bit of the science behind MoveID. So the science, using a scientific model, has allowed us to take advantage of industry standards and best practice, as well as learn and grow quickly. We see this in the expansion of multiple neural networks types used and deployed through our MLOps model. We've expanded to include TinyMLOps to allow us to swap environments that are throughout the networks, and allowing us to continuously deliver tiny packages to the tactical edge. And when they're compromised networks environment, particularly important when decision speed is critical, and that speed has potential for lethal outcomes. The models are trained in the cloud using environmental data gathered via our on-device app. The model uses one of the methods developed for multivariate time series that is CNN on fixed width windows across the sensors value used. CNN comes from deep learning image analysis, learning to create features by non-linear transformations of selections of the input. These features then, via learning, prove useful in the task at hand. The binary classification returned a probability that the input produced has been generated by the user that is supposed to have the device. The model simply runs the data presented. It is fast, very fast, and efficient, and running under 1 megabyte. With other versions of the model, we use RNNs, CNNs, passing the sequence of tuples to the model. And combinations of RNN, CNN, the combinations of CRN and NNN. We have other models in development. The accuracy is well over 99% for each user on the device itself. And the ERR is around 0.04 or 4 in 1,000, which is coming down quite rapidly as we develop more. And you can see, I want you to have a look at this process that we've got up here. Yes, this is for a CNN, but this is the model that will actually be used in the next couple of slides in your mind's eye to make sure that we are doing this correctly. This is me. Well, actually a sub-second slice of me, and was used to identify me at over 99% confidence level. Now, if we remember from the previous slide, our mind's eye, let's overlay that on this image, and you'll start to see how the neural networks will learn about me, continuously be able to identify that it is me or not, and return a confidence score. It's the way that I move, the way that I interact with the environment. We're seeing some very steep pitches here and some very quick downs. We see some twists and turns that make me. This is two subjects, subject A and subject B. And again, if we use our mind's eye, and it's how we each as individuals interact with that environment. So whether I'm 200 meters under the sea or 422 kilometers above it, these things are important. If we take gravity, for example, how I interact with gravity, this leads us to pose. What would this look like in space? or on the space station, where the gravity is artificial or non-existent. Important questions to consider. Then we take acceleration on Earth. It is me, but the change of gravitational forces and what it does. This is why it's important for the TinyMLs. And as we have a look at the subject A and subject B, and we've taken that close up now, we can see how some of the subject A's is very slow to come up and down. But then there's sharp pitches here and there. It goes deep and there's a lot of movement. But subject B has sharper movements, continuously going up, down, and when curving as we're swerving around and taking into account our environments that we're actually interacting with. And then if we have a look and we go further to this and we start slicing this up, and again, if we use our mind's eye to see how the neural networks are slicing the images of me or the two subjects as they twist and turn and interact with each other, and then again with the environment around us. We start bringing this in and we really start seeing how the neural networks are taking slices from here, from the peaks and the troughs, from the twisting, from the turning. And it's these experiences that the neural networks have done. What it's really looking at is how I became me. And into the future, as it continues to learn, as I'm hurt, as things happen to me, I'm out playing football or soccer or basketball, it starts to learn. These activities are really, really important for the system to understand. And again, it's on a device that I am in control of. It knows that it's me.
Fortifyedge, just a bit more about how we work with enterprise customers or OEMs now. So if you're an enterprise customer and have a need for high-grade security and have users that demand this sort of capability, we follow a customer need discovery approach. We understand the task of the users and what they need to do. Our development approach is using what's called MLOps, where we constantly design the collection of data, tuning of models, and deployment in an agile approach. So the work we did with our partners at Microsoft and Thales, we were releasing deployable models on a weekly basis. And if you're an OEM that is manufacturing next generation connected devices, whatever they may be, we're looking to partner with you to OEM our capabilities onto your devices. So everything from personalized authentication inside an autonomous vehicle to AR, VR, wearables, and controlled devices like drones. And one case study of how we have done this OEM partnering is with Thales and Microsoft in the civil defence, first responder and defence personnel space, where we've built a complete tactical edge solution that can be deployed and ruggedized devices, everything that can be deployed anywhere in the world with or without connectivity. I want to thank you again from Malcolm and myself for taking the time to learn a bit about Fortifyedge and our advanced neural networks deployed for IoT. We'll be demonstrating and presenting at a number of conferences upcoming, and we really hope to hear from you. If you're very interested in working with us, please pop onto our website at fortifyedge.com, and we'd love to hear from you. Thank you.